Another test they mention in this section is called test for divergence. Test for divergence. Here it is. If the limit as n goes to infinity of a sub n does not equal 0, then the series sum of the a sub n's diverges. What does this tell me? Yeah. Yeah, we're going to have to look at limits a little bit on some of these. So what does it say? Well, if you've got a series and the a sub n, if that limit doesn't go to 0, you can automatically say it's divergent. It's divergent. If the limit of that, as n goes to infinity, doesn't go to 0, the series diverges. Okay? For example, if I have series 2n squared over n squared minus 1. Here's a sub n. What does the limit of a sub n as n goes to infinity come out to be there? What is that limit? What is the limit of the a sub n's? It would be 2, wouldn't it? However you want to, L'Hopital, divide by n squared. I think that's the way we've been doing it. That'll become 2 over 1 minus 1 over n squared. That's 2. Right? It's not 0. So, this diverges. Because the limit of a sub n does not equal 0. Limit as n goes to infinity of a sub n does not equal 0. It's got to equal 0 for that to even have any thought of being convergent. Okay? Let's test for divergence. All right? What about this one? Limit, series is e to the n over n squared. Is that one convergent? Well, again, since we're looking at our test for divergence, let's look at the limit of a sub n. That's the limit, n to infinity, e to the n over n squared. Well, that's, what are you going to do on that one? It's infinity over infinity, isn't it? Do L'Hopital. L'Hopital it. What do we get? E to the n over 2n. Which is still infinity over infinity, so if I L'Hopital again, get e to the n over 2. Which, what's that limit? Infinity over 2, which is infinity. Not 0. No, not convergent. So e to the n over n squared diverges because the limit of n going to infinity, a sub n does not equal 0. Test for divergence. TFD for short. Okay? So if this is infinity, the limit of that, as n goes to infinity, is infinity. If it's 2, if it's 1, if it's a half, anything besides 0, it diverges. The series diverges. Okay, now, look at this one. Series n over n cubed plus 1. Does the test for divergence tell me anything here? Well, what's the limit as n goes to infinity of a sub n? Well, it's the limit as n goes to infinity of n over n cubed plus 1. So yeah, if you do our divide by n cubed thing there, you get 1 over n squared, 1 plus 1 over n cubed. That's 0 over 1, that's 0. The limit does equal 0. What does the test for divergence tell me? Tells me nothing. Okay? Tells me nothing. The only time the test for divergence tells me anything is if this limit is not 0. If the limit is 0, test for divergence is out. I can't use the test for divergence. Okay? It's still, the series still could converge or diverge. Tells me nothing. I have to use another test. Yes. There's many more tests to come. No. Well, maybe today. Okay? Are you very clear on that point? If this limit is 0, the test for divergence tells me nothing. It's only if that is not 0, the limit, as n goes to infinity, does the test for divergence. But it's a good test. But not in this case. So if that test fails, we go to another. All right. All right. So we've got two tests basically. We've got geometric. We've got test for divergence. Third one is the harmonic series. The harmonic series. The harmonic series is, well, the most basic form of the harmonic series is 1 over n. Series of the 1 over n terms. Turns out the harmonic series diverges. Diverges. So that's another weapon in our arsenal of testing for series divergence or convergence. This series always diverges. Harmonic series. Always diverges. This is not by any means a proof, but if you look at the partial sums, S1 would be 1. S2 is 1 plus 1 half, which is 3 halves. S3 would be, well, it would be the 3 halves plus a third, which is 1 point, this is 1.5. It's 1.8333 repeating. S4 would be the S3 plus fourth, which is 2.08333 repeating. S5 would be S4, that, plus 1/5, which is 2.28333 repeating. S6 is 2.45. S11, skipping ahead, I've got some written out, is 3.0198. Skip ahead, S31, I don't know why I picked those, but It's 402,724. These partial sums, they're not going to any particular number, are they? They just keep going and going and going, upwards and upwards and upwards. I hit 2 right here. I see why I picked 11 and 31, because that's where it crosses over 3. This is where it crosses over 4. Guess what? It's going to cross over 5 at some point. It's going to cross over 6 at some point. There's not going to be a sum for the whole entire series. Not necessarily. It's 1 over n. It's 1 over n. Yes, only 1 over n. Well, we'll talk about that one. Now, yeah, there are other forms of it. If I have 6 over n, that's still harmonic. It doesn't matter what the constant here is. If it's 1, if it's 6, if it's 3 halves, that's harmonic, diverges. If it's 3 over 2n, yeah, that's harmonic, it diverges. Because that's just changing the constant multiplier there. So if it's over n like that, yeah, it's harmonic, and it diverges. But there are some interesting little things that will come up, not today, but later, about some things. Lots to talk about. This one, though, harmonic, it's all we need for now anyway. Okay. So, 3 tests today. Geometric, which sometimes converges, sometimes diverges. Harmonic, which always diverges. And the test for divergence. 3 things in our weaponry here for testing. All right, now let's put some of these together. What if I have series is made up of 2 parts? Is that one convergent? Well, when I have 2 parts like that, can I just look at the 2 parts separately here? Yeah, I can split up sums and differences. This is really just the sum 5 over 2n minus the sum 1 over 3 to the n. That's the best way to look at it, isn't it? What about this one? That one's, what is that one? That's an exponential. So that'll be a geometric. R is a half. Believe that? Yeah, that would sum 5 times 1/2 to the n. You could write it that way. Same thing over here. This is the sum 1/3 to the n. So that one's geometric. R is a third. Yeah, I've got 2 convergent series, don't I? And it's the difference of the 2. So that's convergent, yes. As a matter of fact, I can go one better. What is this convergent to? Well, this one would be convergent to the a over 1 minus r for it would be, the first term would be 5 halves. The r is a half. So it would be 5 halves over a half, which is 5. This one is the a over 1 minus r for it would be, first term would be 1/3. 1 minus a third. So it would be 1/3 over 2/3, which is a half. So this actually converges to 5 minus a half, 4.5. 9 halves. Yeah, that one I did mess up. Is that okay? Believe that? change that one. All right. What about this one? Well, if you got the sum 1 over 5 to the n plus 9 over n, is that convergent? Same deal. I can look at the 1 over 5 to the n plus the sum 9 over n. Well, this one converges because it's geometric. R is 1/5. What about this one, though? Diverges. Harmonic series. What you got there, then? I've got one that converges, the other diverges. Well, the diverges means it goes out to infinity. So I've got a number plus infinity. That's obviously total. So the whole thing then, so this series, what's it going to be? Be divergent. One part of it diverges, the whole thing's going to diverge in this particular setup here. If you're adding two things together, series, one of them's divergent, then that's going to make the whole thing divergent. Because that goes to infinity, even though that goes to a number, the divergent one will, by all means, trump it. Trump the whole deal. All right, one more apparently I need to mention. Okay? All right, what about this one? Sum n squared minus 4 over n plus 2 squared. Convergent? Am I looking at geometric? Mm-mm. Harmonic? Mm-mm. So we only have 3, so what does that leave? Test for divergence. And really, the test for divergence should be one you think about right up front there. Test for divergence, I'm looking at the limit of the a sub n goes to infinity. So I'm looking at this right here. Look at that. So anything about that? Will the test for divergence tell me anything there? I think so. Because that's going to be limit-wise divided by n squared. That's what I'm doing here. 1 minus 4 over n squared. 1 plus 4 over n plus 4 over n squared. That's going to be 1 over 1, which is 1. What does the test for divergence tell me there? Divergent, right? This series divergence. Because if this limit is not 0, that series diverges.